I am a practicing neurosurgeon. I'm also a reporter, but I'm also a father of 3 young girls. And I can tell you the topic of toxic chemicals and the interplay with children's health is very important to me for all those reasons. While I'm not a toxicologist by training nor a chemist, as a reporter I was part of this year-long investigation into this exact issue. And I have to tell you, as someone who has studied the scientific method his entire life, what I found was pretty eye-opening for me in lots of different ways. At the start, for example, of one of our specials, we showed this old ad for the pesticide DDT. Now, in the late 1940s, the ad used to play in the houseware sections of department stores. And the part of the ad used to say that this is harmless to animals and humans. In fact, you'd have a cheerful housewife sort of spraying the chemical all around the house, onto the couch, into the kids' rooms, next to the barbecue. She even would spray the dog in certain situations. At the time, DDT was seen as this great convenience, a safe way to get rid of those annoying bugs, as the ad said. Now, of course, we know better, and DDT is banned in this country. I bring it up as a way of pointing out that as science moves forward, we get a better understanding of risks. We often find out that chemicals we thought were harmless are not as safe as imagined, and one of the best examples I think everybody here knows about is lead. Back in the 1970s, the Centers for Disease Control sent a pair of young investigators to El Paso. The CDC wanted them to look into a simple issue, whether the tons of lead coming from these smelters were causing harm to children in the area. Now, at the time, the way people really thought about lead poisoning, best I can understand, was that it was an all-or-nothing sort of thing. Either you were lead poisoned or you were not. Dr. Philip Landrigan, who you mentioned, Mr. Chairman, and his colleague Stephen Gelbach found children close to the smelter were lead poisoned. That's what they expected to see. They had vomiting, they had muscle weakness, they had convulsions, they had terrible symptoms of lead poisoning. But what they found, something else, was slightly unexpected. Children further away, exposed to much smaller levels of lead, were affected as well. Now, their symptoms weren't so obvious that their parents took their children to the doctor, but we know that lead exposure has a profound, lifelong effect on these kids, leading to all sorts of neurodegenerative problems, a whole range of damage to the brain and the nervous system, and it comes back to the same point. If those adults now, who were children at the time, had only known then what they know now. We all know that no amount of lead is completely safe. I, like you, am not here to say that all chemicals are bad in all circumstances. You can even make a case that DDT, for example, had a significant role in preventing malaria in poor tropical countries where malaria killed a lot of children at the time. But I think the stories of DDT and lead show us that what we don't know can really hurt us. And there's a lot that we don't know. Roughly 80,000 chemicals in commerce today. There's only been required testing of 200 and restrictions on just 5. I think for the average person that hears this, that knows nothing about the chemical industry, those are mind-boggling figures. As a dad and as a doctor, I was surprised to learn this. I assumed that the government, that watchdog organizations, I assumed that they signed off on the safety of these chemicals before they were introduced. And time again, when we talk to experts really all over the country from all different walks of our society, we started to hear the same refrain, that the chemicals in this country are innocent until proven guilty. And the only way that they're ultimately proven guilty is by health effects turning up in people who have been exposed often years, if not decades later. But proving cause and effect is going to be difficult, if not impossible. In science, we expect absolute proof. It's a scientific method to which I was referring, but we don't always have it. The problem is 30 years from now, a devastating health problem may emerge, just as we saw with lead. We talk to people in the green chemistry industry right here in this country, people who have years of experience trying to figure out how to make the same products in less toxic ways. They told us they seem to believe that the opposite would occur, in fact, if the precautionary principle were adopted. These green chemists seem to say that it would it would spark innovation, and that the industry would come up with new ways to try and create these products with fewer hazardous chemicals and emerge as profitable as ever. The disagreement, the difficulty, the rub, so to speak, is going to be over the best way to measure risk. I think that's really what it's going to be. Do you measure single risk? Do you measure aggregate risk? How do you assign responsibility? How do you assign, responsibility for trying to improve the chemical safety record, whether it be a specific company or be an organization? I think that's going to be difficult, and it's really at the heart of determining whether a particular chemical is safe. So I think lots of agreement, and that one point is probably the area where when we were investigating, we found it seemed to be the biggest area of friction.